application of Thales' theorem, which basically just says if a triangle is inscribed within a circle across the diameter AC, then the angle ABC is equal to 90 degrees. There's loads of YouTube videos and internet sites you can have a look at to prove that that's right, but that's just a fancy way of saying that this angle here is 90 degrees. So if our task is to find theta, alpha and beta, well, we're on our way, because what we can say is that we know that the interior angles add up to 180 degrees in any triangle. So if we just look at this big triangle for now, we know that theta, which is what we want to know, plus 58 degrees plus 90 degrees equals 180 degrees. Now 58 plus 90 is 148. So theta plus 148 equals 180. Now, so therefore we subtract 148 from both sides, and we get, what's that? 180 minus 148 would be 32. What am I talking about? No quick maths here. So we know that this angle in here is 32 degrees. The next thing we have to find out is alpha and beta. Now, the way we can do that is we have to recognize one little trick to make this so much easier. We know that this distance here, let's call that r, is the radius of the circle. We also know that this distance here is r, is the radius of the circle. And there's another radius on this angle here, on this line here, so that's the radius as well. So what we can say is OB is equal to OC, which is equal to OA, which is really useful, because if we just look at this triangle here for now, this right triangle, it's not a right triangle, but it's the triangle on the right, this triangle here, we can say that it is an isosceles triangle. It's an isosceles triangle because it has two sides that are the same length. And this is the trick you have to remember with this question, is an isosceles triangle has base lengths that are the same. So this one here is 58. Because it's an isosceles triangle, this one here must also be 58. So we know that beta equals 58 degrees because we've created an isosceles triangle where two of the side lengths are the radius of the circle. If we play the same game over here, we see that we have the radius, we have two radii, which makes this triangle on the left also an isosceles triangle, which means the base has an angle of 32 degrees as well. Now, because that matches up with this angle over here, this theta angle, which we worked out before was 32. Now all we have to do is, we know that it has to all add up to 180 degrees inside this triangle. So we just say 32 degrees plus 32 plus alpha equals 180 degrees. Now 32 plus 32 is 64, plus alpha equals 180. Now let's see if I can work this one out a bit quicker. 180, if we subtract 64 from both sides, gets us to 120, and then subtract another 4, gets us to 116. So there we go, we've worked out alpha, worked out beta, and we've worked out theta.